What's going on, everyone? My name is Johnny Bandon and I'm your CCNA instructor for this CCNA video series. And in this video series, we're going to cover our last section of our IP services, and that's going to be SSH. So before we begin teaching, I just want to give our little sales pitch. If you're looking into some certification training for either your unit or organization, or some more advanced individual training via Zoom or in person, please feel free to check out our website, trepatech.com. It's listed right here to learn about our course offerings. All right, now that we got that out of the way, let's go ahead and jump right into SSH. So SSH is a very important IP service, or really technology, that we use as network administrators, and you use it probably every single day if you work in a networking job. Even if you're not, if you're a server admin, sysadmin, you work in the cloud, you do file transfers securely, more than likely you're using SSH. So let's jump into what SSH actually is. So first thing we're going to touch on is our agenda. So we're going to go over a quick overview of SSH, right? Just quick 3 bullet points of what it is, why we use it, what's the purpose, why was SSH made, and why do we use it? And then how SSH encrypts. This isn't a security course. We're not going to dive too deep into RSA or asymmetric versus symmetric encryption, but we're going to kind of just go through the sequence of what SSH does or how it accomplishes encryption. And then we're going to go over why network engineers is important. Why do we need to know about SSH? When do we need to troubleshoot it? And when do we use it in our network? All the time. And then we're going to go over configuration, and then we'll have a quick lab after this, just going over the configurations we learned. Okay, with that being said, let's go ahead and get started. I'm going to minimize my face here because it is not important for the lesson. So, quick SSH overview. So SSH stands for Secure Shell, and that's going to be a network protocol that is used to establish what we call a secure and encrypted connection between two systems. And that bullet point says over an unsecured system. Essentially what this is saying is that if I need to SSH over an untrusted network, so if we have trust boundaries, right, and security, the internet is, or your ISP, is untrusted because we don't know what's going on in there, who's capturing what packets, something out of our administrative control. So we can use SSH to make those secure remote connections over an untrusted network or an unsecured network. And typically you see that being done over the internet, but SSH is also used in the enterprise. No one really uses any alternatives anymore when getting into the CLI of a server or a network system. And then SSH enables remote login to a system and secure data transfer between systems. And it's going to be able to use what we call public key cryptography. So this is getting into what I talked about asymmetric versus symmetric. So the beauty of RSA or SSH is that it uses both. It's going to do a key exchange using public keys to secure that key exchange, but then it's going to use symmetric encryption to actually encrypt the data. And we're going to get into that. But essentially you can use a public key cryptography, so actually creating kind of like a certificate, and there's certain requirements you need to actually create those RSA keys. This comes important when you're on the CLI, enabling SSH on your network device. And then SSH allows users to run commands and execute programs on remote systems securely and efficiently. This is just to say that as an admin, if I need to access this server CLI, I'm going to use SSH. And SSH is that transmission protocol or transmission application, right? Because the protocol may be TCP, that allows that secure transfer of me typing in to the CLI what should be executed on that server or that network device. Okay, why we need SSH? So if we didn't have SSH, if we're using a protocol like Telnet, that transfers everything in plain text. So if we're doing any eavesdropping, and in the middle of attacks, anyone sniffing our network or capturing packets on our network, we'll be able to see every command we send across via Telnet. So we need SSH to provide that secure remote access. It's going to prevent attacks like eavesdropping. And then SSH is going to use that strong encryption like AES and RSA, and that's going to protect the confidentiality of your data actually being transferred or when it's transmitted. And then we can also prevent brute force attacks because SSH can support some key-based authentication. So what this means is you can actually integrate some certificate-based stuff in SSH instead of just doing username and password. Because when you just have a username and password, those are always subject to, password attacks like brute force, dictionary, spraying attacks. All right, then how does SSH encrypt? So SSH is going to use a combination of symmetric and asymmetric encryption to establish a secure connection. So just to quickly do a quick note of what the difference is. So asymmetric is going to use what we call key pairs, meaning it's going to use a public key that's going to be available to anyone in that, either that PKI infrastructure, really anyone globally that needs to use that public key. And then it's going to use a private key that should only be known to the sender of that private key, right? The owner of it. And asymmetric encryption, what it allows a sender to do is go ahead and grab that public key to encrypt data being sent. And then when it sends that data to the recipient uses its private key. So essentially in asymmetric encryption, what we have here, I'll draw it down here. Let's say Bob needs to talk to Alice over here. Here's Bob and Alice. The typical names you see in like all IT books when describing a user, right? Let's say they want to send just any data. Let's say they want to send data using asymmetric encryption. Well, what's going to happen is if when Bob wants to talk to Alice, Bob is going to grab Alice's public key. And that's going to encrypt the data. And then whenever Bob is sending an email, text message, whatever the case may be, when Alice receives that message from Bob, she is going to decrypt it using her private key. So you kind of see how those key pairs work in conjunction. So you're going to use the recipient's public key to encrypt, and then the recipient's going to use its private key to decrypt. So RSA does a combination. Because one of the shortfalls of asymmetric encryption is the compute power, right? It's not as quick. It doesn't computationally encrypt data as fast. So what SSH is going to do is use asymmetric encryption to initiate that session. And then once they have that SSH session established, they're going to use a symmetric encryption algorithm to encrypt that data, giving it that speed, right? That transfer speeds that we need. And symmetric encryption only uses private, or more commonly known as secret keys. I mean, they're both pretty common, the terminology. But they mean the same thing in terms of symmetric encryption. Keys that should only be known to the client or only be known to whoever creates that key. And if you need to exchange private keys to do encryption and decryption, you need a secure key exchange protocol or algorithm, which SSH provides in that combination. So you can see kind of the steps here. So this SSH client is going to initiate a SSH connection. The server is going to respond. The server responds essentially with its public key. The client's going to encrypt with the public key and send to the server. And then once that authentication is passed, they're going to agree on what we call a session key. So they're going to agree on a secret key to be used for their symmetric encryption down here. And that's when they start sending encrypted data to each other. So that's kind of the simple steps how SSH works. Not anything that's going to be tested on the exam, but it is important to know. And then for network engineers, so why do we need to know about it in networking? Because we use SSH to access all of our Cisco devices, our routers, our switches, our firewalls, even access points, wireless LAN controllers. We can use SSH to remotely access the CLI on all these different network devices. So iOS, right? Cisco iOS, which is what we pretty much focus on here as far as routing and switching in the CCNA, can be established and created via the CLI. And it can be used for inbound and outbound connections when we create this SSH key or these RSA key pairs. So now let's go ahead and jump right into the SSH configuration. So a lot of times in configuration in Cisco, when it's global, right? Not necessarily for a specific interface or specific protocol, there's not really a sequence or order to things. There are cases where there is a sequence in order to how you configure something. And that's going to be with SSH. There is a sequence. So I have 3 slides here going over configuration. These are the kind of the in order steps, okay? Now, what do we mean by that? So for SSH to work, we need to generate what's called an RSA key. And that's how we're going to do that asymmetric encryption, right? So to create that RSA key, you need a couple things created before you can generate that key. What you need created is a host name, an IP domain name, and what that does is give that RSA key a fully qualified domain name to use in the certificate or key it builds for RSA. It needs that information. It needs the host name, domain name, that fully qualified domain name of the device that it's creating this RSA key for, the public key. You're also going to need a username and password, local. And you're going to need this when you're doing those SSH connections and for that RSA key. So you're going to need to create username and password because you can't just SSH without any authentication. That's the whole point of it. You need to be authenticated. So we create that local database with a user and password on our iOS device, either router or switch. And that's what someone's going to have to use when they want to remote into our system. If we don't have any, TACX or radius configured, we're just doing local credentials. So there is a sequence. Now, it doesn't matter in which order you do these commands, but these 3 commands have to be configured and done before you generate your RSA keys. So set a host name, create local credentials, and then give a domain name. We'll go over what this privilege means when we get into our next section going over like security in iOS. It pretty much sets authorization levels. But yeah, it's really that simple. These 3 commands right here. Awesome. And now we're going to get into actually generating the RSA key pairs. So that command is going to be crypto key generate. And then you choose RSA. Those are the keys you want to make. And then you got to pick the bit size or the bit key size. So again, this isn't a cybersecurity course. This isn't CCNA or CCNP security. So we're not going to get into the nitty-gritty details of these RSA key pairs. But just know that the higher the bit size, the stronger the encryption is, right? And that's kind of that is the golden rule. That is the standard for any encryption algorithm, any hashing algorithm as well. So if you didn't do those 3 commands that I showed you, host name, user credentials, and domain name, you will not be able to execute this command. And we execute it here, you're going to see some output. It's not an error. So on this device, I already had an RSA key pairs defined. So this is just letting me know they're going to be replaced. And then this is saying the key module size is 2048 bits and it's generating it for us. And then they say, okay. And that's it. We created SSH. And then there's another command I just want you to know about, IPSSH version 2. This is actually not necessarily needed after this command. Essentially, sometimes if someone, for some reason, wants to create a modulus key pair size of, let's say, 1024, that's not going to be SSH version 2. That's going to be version 1.99. So this is kind of just a quick way to make sure that we upgrade that key pair to version 2 or that we're using SSH version 2. Just a quick, easy thing to do. Okay, then finally, we got to tell the iOS device that we want you to accept SSH connections and we want you to be able to use SSH connections. So really the accepting the inbound connections at SSH, that is this one command here, transport input SSH. So what you're going to do is go to your V2I lines. On a router, sometimes you only have 5. On a switch, you have 16. You're going to get into your VTY lines, which is your remote access terminal lines on an iOS device. And you're going to put how you want to log in remotely. So here we're saying we want to log in using those local credentials. That's what login local is. If you have like Cisco Identity Service Engine, some TACX, some .1x, you have network access control on all your routers and switches, this may be login authentication default, which is essentially saying, okay, use those AAA commands we configured earlier to tell you what credentials you need to use to log in. But in this scenario, we created a local database with a username and password. So that's what we're going to use to log in. And then this is the key command here. You have to say, hey, you're going to accept SSH connections. At this sub-interface prompt, at this command line interface prompt, you have a choice. You can either put telnet here. Depending on the iOS version, there's like our login. A bunch of different ways you can do remote connections to your iOS device. But here, we're worried about SSH. You need this. And this is going to say only accept SSH. You could also put all after here. And that means accept all remote connections. But in the case of SSH, when they ask you on the exam, if they do, how do you make sure that you're only allowed to use SSH? That's how you do it right there. Transport input SSH. Then verification, you can do this command show IP SSH, and that'll show you the version right there. And then it'll show you the key, which is just a bunch of nothing. But all right, that is going to be SSH. Very simple. Before we go, I want to just take a look at the CCNA exam objectives with you guys. So let's go to exam topics. They used to just have an easy PDF. Maybe I'm doing the search wrong. Then we go to IP services. We can see it's just all we need to do is know how to configure network devices for remote access using SSH. So this whole PowerPoint slide and training is a little extra, right? You're learning a little bit deeper into what SSH is, which is always good. You're always going to be using SSH in your IT career. With that being said, let's go ahead and end this video, get into the lab. I want to thank you all for viewing. And again, if you're interested in some more personalized training, live virtual training, or boot camps, please feel free to check out our website to learn more about how we can support your military unit, your government organization, or your corporate environment. Thank you for viewing this video.